Hey there, let's talk about motion diagrams. A motion diagram is a combination of a strobe diagram, position versus time graph, and a velocity versus time graph. Sometimes we include an acceleration versus time graph as well. A strobe diagram is a composite image. It's a series of images of a particle taken at equal increments of time. This is a strobe diagram of a bouncing ball. The images are closer together at the top of the bounce when the ball was moving more slowly, and farther apart at the bottom of the bounce when the ball was moving faster. This motion diagram shows a particle moving at constant speed. You can see the images are spaced evenly, and the arrows are all the same length. The position versus time graph has a constant slope, and the velocity graph has a constant value. Remember, the slope of the position graph is the value of the velocity graph. This motion diagram depicts a car slowing down. The images are getting closer together at the later times because less distance is covered in the later time increments. Arrows get shorter in length, and the position graph has a decreasing slope and the velocity graph has a decreasing value. This diagram shows a car speeding up. The images are getting further apart because more distance is covered in the later time increments. The arrows get longer, and the position graph has an increasing slope while the velocity graph has an increasing value. In general, strobe diagrams show the motion of a particle. The image of the particle advances at equal time increments. The faster a particle is moving, the farther apart the images. The arrows of a motion diagram indicate speed and direction. The direction of the arrows, the direction of motion, and the length of the arrow shows the speed of the particle. The strobe diagrams can be coupled to position versus time and velocity versus time graphs.